Okay, so rational inequalities, for these, we're going to have ones where they're not at the very beginning greater than or equal to 0 or less than or equal to 0. All right. So we need them to be either greater than 0, less than or equal to 0, something like that, in order to solve, because with our testing our signs, we can only really do that if we're talking about something being positive or negative. It would make it really difficult if we had to like plug in values test here, where we're not just looking at signs. So what we want to do every time is we're going to move everything to one side. So we're going to have 6 over x plus 3 minus 2 over x is greater than 0. And I said to put the 0 on the right. Technically, you could put it on the left, but it just makes life easier if it's on that right, because we can now be thinking about this as greater than 0, which tells us we're looking for positive answers here. If you don't do that, then your answer, if you have it on the left-hand side, it's a little bit trickier there. So from here, we want to get like denominators and combine. So this is like solving those equations. We need all of our denominators to match. 2 of them already do. We just have that 3 right there that doesn't have a denominator. So we would just need to multiply that by the x on top and bottom. And so we will get 6 plus 3x minus 2. And then all of them have the same denominator. We cannot drop it with an inequality, right? Because that x in the bottom, it's not going to change the number, but it will change the sign. So we have to keep that x right there. So that's the biggest difference between the equations and the inequalities there. So we can't drop that denominator. We've got to keep it. And then we do want to combine this a little bit further. So that 6 minus 2, that's going to give us 4. So I'm going to write it like this, 3x plus 4 over x is greater than 0. Okay. Now, at this point, we're where we were at yesterday. This, sorry, looks like what we had yesterday. Sorry, I'm going to check that. Sorry. We'll make it. Okay. So we just take the top and the bottom, set them equal to 0. That's going to give us our numbers to put on our number line. This is a pretty small one. You can make the chart if you like or not. I'm going to make the chart. I just like the chart. So, for this, we've got 3x plus 4. So if I think of plugging in a number less than negative 4/3, so something like negative 2 or negative 3, negative 4, say negative 4. 3 times negative 4 plus 4 is going to give us a negative there. But if I plug in something here, like negative 1, 3 times negative 1 would be negative 3 plus 4. That'll give me a positive in that section. And then anything bigger than that is also going to be positive. Whenever we have just x, if we plug in negative, we get negatives. If we plug in positive, we get a positive. So we'll set up that chart there, and then if we have an even number of negatives, we'll get a positive for our answer. If we have an odd number, we'll get a negative. So we'll end up with positive, negative, positive. I bet the next slide was really where I'm supposed to be doing all this work right here. I just realized. Hopefully you guys are ahead of me there. So I was choking there for a little while and just didn't even think about it. All right, so you'd factor the numerator to denominator, get zeros that go with each binomial. We did that. Put the numbers on the number line, test the point. The region that makes the inequality true are your answers. That we should have been working on the other side, but I didn't, so I'm just going to finish up here. So we're looking for positive answers. That is this section right here and this section right here. So to write that answer, we would have negative infinity to negative 4/3. This one's an easier one because it's a greater than sign. We don't have to worry about brackets. We're just going to do everything parentheses. And then we'll have 0 to infinity. So this would be our answer there. So it's the same as Monday, but we got those steps at the beginning that are going to add to it. Okay, let's move on to our next example. Now, this is one that sometimes gives students a lot of problems because if that were an equal sign, we might want to cross multiply for this one because you could do that if it were an equal sign. You cannot do that whenever it's an inequality. So inequality limits what we're able to do. So we got to move everything to one side. So that's going to give us 2n plus 1 over 3n plus 1 minus n minus 1 over 3n. Plus 1, and since nothing's left on that left-hand side, it's going to be less than 0. So, these two already have common denominators, so we can go ahead and combine them. What you have to be really careful of here is this negative. It's got to get distributed to both of those, both the n and the negative 1. So we'll have 2n plus 1 minus n plus 1. And their denominators are the same, so we just write it one time. And if we combine our like terms in the top there, we're just going to get n plus 2 over 3n plus 1. Okay. Questions so far? All right, that's the new part. From here, it's just like what we were doing on Monday. So we'll take each one of these. N plus 2 is going to equal 0, which means we'll get negative 2. And 3n plus 1 will equal 0, so we'll get 3n equals negative 1, divided by that 3, n equals negative 1/3. Oop, I wasn't looking at that negative. Got them in the wrong order. And so I like the chart. So, again, we're just plugging in numbers. So if I plug in something like -3, negative, but something like -1, the pause here, give me a positive, so I'll get positives there. -3 would give me a negative here. -1 would still give me a negative, but then something like 0 would give me a positive there. So we'll end up with positive, negative, positive for this one. And Reese, which ones are our answers, the positives or the negatives? So whenever we look at this line right here, tells us whether or not we have a positive or negative. Which ones are the parts that we're going to use as our answer? The sections where we have positives or the sections where we have negatives? Is negatives. How do we know? Right, so right here, want to move everything to one side, we got less than 0, which tells us negative. So negatives are our answers, so we would just have -2 to -1/3 as our answer here. And again, we don't have the or equal to sign, so we don't have to worry about brackets. It's all going to be parentheses. Okay, questions? All right, let's try this one. All right, so we're going to move everything to one side. So that's going to look like this, 3 over x minus 3 minus 2 over x plus 2 is less than or equal to 0. And so this one we do not have common denominators, so we need an x plus 2 for that first one. And then the second one doesn't have the x minus 3, so we need the x minus 3 there. Technically, you could think about doing it with that 0, but because it's 0, it's just going to stay 0, so we don't have to worry about that. So again, you cannot throw your denominators away with the inequalities. So you have to keep those for the inequalities. If it was the equal sign, we would just cross out the denominators here and solve from there. But we can't do that here. So we're going to get 3 times x plus 2 minus 2 times x minus 3. And since the denominators are the same, we can just write it once, x minus 3, x plus 2. And we need to combine everything in that numerator. We don't want to multiply the denominator together because for that denominator, if we do multiply it together, then we're just going to have to factor it back out whenever we're looking for those zeros. So we'll just leave it like it is. But the numerator, we got that minus sign, so it's got to be combined. So we got 3x plus 6 minus 2x plus 6 over x minus 3, x plus 2. And if we combine our like terms there, we're going to get x plus 12 over x minus 3, x plus 2. So, I'm going to give you a minute. I want you guys to try to finish this one on your own. I went ahead and did my chart here. So on your number line, you should have a negative 12, negative 2, and 3. And hopefully, for your answer line, you get negative, positive, negative, positive. So, to give our answers for this one, Hallie, are our answers going to be the negative sections or the positive sections? Negative, because right here, we've got that less than or equal to 0. That tells us negative. So we're looking at these two sections right here as our answers. So I'm going to use brackets at first, but then we'll go back and think about whether or not those can actually be brackets. So I would not use a bracket with this negative infinity because we never use a bracket with infinity. You can't actually get there. And then I'd have negative 2, 2, 3. But I need to go back and think, what is in my denominator? And in my denominator, I've got 3 and negative 2. Those are the values that would give me zeros in my denominator. So negative 2 and 3, I can't actually plug those numbers into the equation because I'll get zeros in the denominator. So I'm going to go back now, and my negative 2 and my 3, I'm going to change those back to parentheses. So the negative 12 actually ends up being the only part that you have a bracket for. Now, these are super long problems, so if you got to the very end and the only thing that you got wrong was brackets and parentheses, that would probably be, at most a point, maybe half a point for that, if that's the only thing that you got wrong. Because it's important for us to be precise, and to be precise we need the brackets in the right places, but in the grand scheme of things, you pretty much got the idea. Questions? All right, let's see. Let's see. Yeah, I kind of do. We're doing pretty good. Let's do both of these. All right, so for this one, the main reason I want to do this one is because it's going to be a little bit different because I've got 4 minus x instead of 5 minus x instead of x minus 4, which is going to make our chart just a little different than we've seen before. So we're going to move everything to one side, x minus 3 over 4 minus x minus 5 minus x over x should be less than or equal to 0. And so our denominators here, I've got 4 minus x and x. So Jackson, for that first fraction, what should I multiply my denominator by? Not 4. So for this first one, I've already got this 4 minus x. I need this piece of the denominator that I don't have. So we're just going to multiply by that x. There. And then for the second fraction, I need this denominator to look just like this denominator. So what should I multiply by here, Jackson? Well, for the whole thing, 4 minus x. Yeah, because what we want is our two denominators to be exactly the same, right? So over here we've got an x, 4 minus x, and right here we got the x, so we need to add the 4 minus x in. If we multiply the denominator, we must also multiply that numerator. There. Now I'm going to write this next step down. Some of you may go ahead and distribute here. The main reason I'm writing this down is because students have a hard time knowing what to do with that second piece there sometimes. So right here, most everybody's good with distributing that x. So you got x squared minus 3x. Right here is where I usually see students struggle, because you got to multiply those two things together. First of all, sometimes they don't put parentheses. So if you don't put parentheses, it starts to look like you only need to distribute maybe an x or something. But you need parentheses around each one of those. So I'm going to treat it like we got some brackets right here, and I'm going to multiply those two binomials together first. But you have to keep whatever we get when we multiply these, we need to keep them in brackets, because this negative right here is going to have to be distributed to all of it. So I'll get 20. I'll get a minus 5x here and a minus 4x here, which is going to give me a minus 9x. So I'm sort of shortcutting that in my head by combining those two. And then I'll get a positive x squared. And now I need to make sure I distribute that negative to these. So it's going to give me x squared minus 3x minus 20 plus 9x minus x squared. And my x squareds are going to cancel. Looks like I'm going to get 6x minus 20 over x times 4 minus x. So, from this point, it's the same as we've done before. We're going to have 6x minus 20 equals 0, so that's 6x equals 20. We'll divide by 6. So x will equal, so that'll reduce to 10 thirds. And then we'll get x equals 0, which is just x equals 0. And then we'll get 4 minus x equals 0. I like to just add that x over to the other side. That way I don't have to divide by negatives and whatnot. So we're getting 0, 10 thirds, and 4. 10 thirds would be like 3.3 repeating, so it's a little bit smaller than 4. So when we put this on the table, 0, 10/3, and 4. So we'll make our chart. And so 6x minus 20, if I plug in -1, I'll get a negative. If I plug in 1, I would still get a negative. But if I plug in anything bigger than 10/3, I'm going to get a positive. It's not so easy to pick a number there. It's going to be like 3.5. But you also know, like, at 10/3, 6x minus 20 equals 0. Because we said equal to 0 there. So that should be where it switches from negative to positive. For x, if you plug in a negative, you get a negative. If you plug in a positive number, you get a positive. So it'll look like that. And be careful with 4 minus x. If you're very carefully going through it, you'll be fine. But you may have been starting to notice that it usually goes negative first and then switches to positive. It's not always the case, because here, if I plug in something like -1, I got 4 minus -1, which becomes positive. I actually get a positive right here. So you're going to start off with positives for this one. Same thing if I plug in 1, 4 minus 1 would be positive. I'm even going to get like if I plug in 3.5, that would fall in this category. I would still get a positive here. And so the negative shows up there on the end. And so we'll get positive, negative, positive, negative. So, let's see, which ones are going to be my answers? The positive sections or the negative sections? Negative. Because over here, for my original equation, or here, wherever you want to look, we've got less than or equal to 0. So that's negative. So we're looking at this being our answer and this section right here being our answer. Yes?
Between 10/3 and 4 being negative for 6x minus 20.
10/3 is like 3.3. So you would have to plug in like 3.5 there. And I think that should still give you a positive there. If we do like 6, 3.5. Yeah, I'll give you 21. Yeah, so I think you should get a positive there. Okay, so we'll be dealing with brackets here. So we got 0 to 10/3 and 4 to infinity. But anytime we use brackets, we've got to go back and ask ourselves, wait, which ones can these not actually equal? And what numbers, Grace, can we not have in our, because it's going to give us 0 in our denominator? 0 and 4. Very good. So we'll go back and we will take that 0 right there and that 4, and we will change those back to parentheses there. Okay, questions? Yes?
So when you plug them back in the denominators and they make 0, you change the bracket to parentheses?
Correct. Yes. Yes. Very good. The only time you don't have to worry about Jackson is if you have a less than or a greater than to begin with, just use parentheses the whole time. But if you got that or equal to, you got to worry about it. All right, let's do one more, and I'm going to let you guys work some on your own. So this one is a pretty big problem. you still need to move everything to one side first. So 2x over x minus 5 plus 3 minus 4x plus 1 over x squared minus 6x plus 5 is greater than 0. Alright, so we want to factor this denominator right here, and it will factor into x minus 5, x minus 1. So this denominator already has an x minus 5 and x minus 1. Over here we have an x minus 5. So, Maddox, what do we need to add to it, or not add to, but multiply by? We need an x minus 1, so we'll do x minus 1 there in top and bottom. Our 3 does not have a denominator at all. So that means it needs both, right? So we need an x minus 5 and an x minus 1. There. And our 4x minus 1, it already has both in the denominator, so we don't have to multiply it by anything. So, I'm going to write this whole step out here to be really clear what we're doing. So we got 2x times x minus 1 plus 3 times x minus 5 times x minus 1 minus, they're not written here, but you really need some parentheses around that, 4x plus 1 there. Oh, I don't know why it does things like that. Because you got to distribute that negative. So right here, here's that thing that a lot of students mess up. You need to multiply these together and then you can distribute the 3. Or you could distribute the 3 to the x and the 5 first and then multiply those together. Just make sure you don't distribute it to all 4 of those because that would not be correct. So we'll get 2x squared minus 2x. I'm going to just let this 3 hang out front for right now. I'm going to multiply these two binomials together. So x times x is going to give me x squared. X times negative 1 is going to give you negative x. Usually I do that part in my head, but I haven't. Let me go back and just do that in my head. That means having to write this whole thing one more time, which I want to avoid. So right here I'll get negative 1x and I'll get negative 5x. So I'll get a negative 6x in the middle, and then plus 5. And then if you want to, you can go ahead and distribute that negative. You got minus 4x minus 1. And the 3 has to be distributed here. So we're going to get 5x squared. Then we'll have, let's see, negative 24x. That'll get all 3 of those taken care of. And plus 14. hope that factors. It doesn't factor, does it? Alright, double check me to make sure I haven't messed up in the beginning. Okay. I feel like I meant for that factor. There's another way we can do it. I don't know how to sign up it. Let's see here. Alright. Before we go any further, we're going to do what you need to do when you're at home and you do something like this. The answer that we get here, or I've messed up. So, photomath is a great tool when used appropriately. If it can even do this one, I don't know. We'll see. Might not be able to handle it. No, it works. Yeah, okay, we're going to have to do this. Alright. Okay. So, I don't think that I will give you one that won't factor, but just for fun, I don't know if this will, I know this will not factor, and I don't think you'll see one like this on quiz or test, but just for fun, I need to set everything equal to 0, right? Which means I got to do x minus 5 equals 0, which is easy, x equals 5. And then x minus 1 equals 0, which is also easy, x equals 1. It also means that numerator, 5x squared minus 24x plus 14, I got to set it equal to 0. How do I solve that? I could complete the square or quadratic formula. So either one of those will work here. Let's just go with quadratic formula, mostly because I would have to divide off that 5, and it's not going to go evenly if I complete the square. So things are going to get messy. We'll have 24 plus or minus square root of 24 squared minus 4, what's in there? 4 times 5 times 14 all over 2 times 5. And then that's going to give us 24 plus or minus that calculator. 24 squared minus 4 times 14. Get 296 all over 10. Now, we could break that down and simplify it, but because I need to make a number line, and if I get something like 7 plus or minus the square root of 31 over 10, that's not going to be very easy to figure out where it lies. Let's just go ahead and get a decimal for this, because we're already outside of the realm of what I'm probably going to give you anyway. So if I do the positive, if I do 24 plus square root of 296 divided by 10, I get 4.120. And then if I do the negative, 24 minus the square root of 296 divided by 10, I'm going to get 0.680. if I round those to 3 decimal places. So we could make a number line here. And we're going to have the 0.680 first, then 1, then 4.120, and then 5. So our chart would have 5x squared minus 24x plus 14, x minus 5, x minus 1, and then the answer. So this x minus 5 will be easy. I'm going to skip to it first. You'll get negatives until you get up here to the 5, and they'll be positive. The 1 is going to be negative, negative, and then positive after that. The tricky part is the x squared plus minus 24x plus 14. So if we plugged in 0, we would get 14, so that would be positive. A number between 0.680 and 1, I promise I will not give this to you without a calculator. I probably am not going to give it to you anyway. Maybe as a bonus or something, but if I give it to you, you will have a calculator. So let's plug in like 0.75 times. So 5 times 0.75 squared minus 24 times, 5 times 0.75 squared minus 24 times 0.75 plus 14. That gives me a negative right there. Something between 1 and 4. Let's do a 2. I'm getting still a negative there. I got negative 14 when I plug that in. And something between 4 and 4.120 and 5 is going to be something like 4.5. That gets me positive, and I bet that last one's going to be positive, but let's check. It's positive also. So we'll have this, and then that's going to be positive here, negative here, positive here, negative here, and positive here. So, Caitlin, which parts are answers, positives or negatives? Positives. So we're going to have these 3 sections as our answer. It's just a greater than, so we don't have to worry about brackets for this one. So we would just have negative infinity to 0.680, 1 to 4.120, and 5 to infinity. And that would be our answer there. You're probably not going to see this unless it's a bonus, but it was extra fun. For those of you, go home and show your parents problems like these, and they'll be like, oh, my baby's so smart. I can't believe they can do this hard math. Well, most of your parents will be like that. Connor's mom may not be impressed. So, you don't think they believe that you could really do it? Or that it was right?